quadratic formula, the basics. So this should be hopefully a review for you. We've at least talked about the quadratic formula. You may have sung a song or two to help you remember the quadratic formula. And now we're going to just take a few minutes. I promise this will be a quick video just about the general plugging in of the A, B, and C values. So hopefully you remember the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You may remember the video of my kids singing the song to you. Hopefully you remember it from there. If not, we'll sing it in class. So one thing before we get into messing with the formula itself, the part that's underneath the radical, the b squared minus 4ac, has a name. It's called the discriminant. And the discriminant of the quadratic equation, that b squared minus 4ac, tells you about the roots of the equation. It tells you if there's two distinct real roots, so like this, or one distinct real solution, so that's what we call the double root, or there are two distinct non-real, so there are two complex solutions. So remember when we were doing the Graph Master Boogie, we would show these and we'd shout out whether there's two real, one double, or two complex, and the discriminant tells you that when you take it from standard form. So it's always a good idea to plug that in and to use the discriminant before you start, so you know what to expect as far as the roots. So let's take something like this, where we have 3x squared minus 10x plus 3. We have the values for a, b, and c. Remember that it goes ax squared plus bx plus c. So we just plug in those values. A is 3, b is negative 10, and the c is 3. So we could do the b squared minus 4ac to come up with what the solutions are. So I'm going to write this out first. So x is equal to negative b, which is the opposite of negative 10, so that's positive 10, plus or minus the square root of b squared, which is 100, minus 4 times a times c. And that's all over 2 times a. So that b squared minus 4ac, that's 100 minus 36, which is 64. So that's a positive 64, so that means that it has two real roots. So we know that just by looking at it. So as we start simplifying this, we get 10 plus or minus the square root of 64, as we just talked about, over 2 times 3 is 6. Simplify this even more. 10 plus or minus 8 over 6, which gives us two things. It gives us 10 plus 8 over 6, and or 10 minus 8 over 6. Simplify each of those. 10 plus 8 is 18. Divided by 6 is 3. So we get 3, or 10 minus 8, which is 2. 2 over 6, which is 1/3. So those are our two real roots, 3 or 1/3. So those are the places that that graph would cross the x-axis. That's really all there is to it. There's nothing else to do. We'll do one example that maybe doesn't have two real roots as a solution, something like x squared plus 4x plus 10. So a equals 1, b equals 4, c equals 10. So b squared minus 4ac, that's the stuff under the radical. We get 16 minus 4 times 1 times 10. So that's 16 minus 40 with a minus 24, which gives us two complex roots, because that is negative. So now we'll do out the formula. Negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. this equals negative 4 plus or minus, we already did that out, negative the square root of negative 24 all over 2, which can be simplified to negative 4 plus or minus, that negative under the radical is going to give us an I, and 24 can be 2 radical 6, that's all over 2, so that's going to give us, the 2 goes into both of those, so we get negative 2 plus or minus I radical 6, so our two roots are negative 2 plus I radical 6, negative 2 minus I radical 6. So those are our two complex roots. And that is everything that we need to know for now. Have fun. See you next time.